The symbol infinity can also be used to indicate that an independent variable is increasing or decreasing without bound. In other words, x approach plus infinity or minus infinity. We write x goes infinity to indicate the x is increasing without bound throughout positive values. We write x goes minus infinity to indicate that x is decreasing without bound throughout negative values. So if you consider the Cartesian coordinate system, in the first case, x goes to plus infinity. In the second case, x goes to minus infinity from the left side of the graph or Cartesian coordinate system. We begin by considering power function of the form x to power p and 1 over x to power p, where p is a positive real number. Okay, p belongs to positive real number. If p is positive real number, then x to power p increase as x increase. For example, x square. By giving some values you can sense. So when x is 0, p is 0, p is 2, okay, let's case p is 2 case. So our first function is f of x equals x square, and second function, let's say g of x, 1 over x square. In the second case, that means this is the x to power minus 2. So p is negative, maybe you can consider. So both cases include all p values for the function x to power p. So we compare these two graphs. For the special case, p equals 2. So if x square graph, maybe x cube can be different, but for the positive x, let's consider graph like this one. So let's use the blue color. So this graph is x square graph. From when x is negative, there is no problem. Again, this is that part. If p is 3, it will be different, okay? But when x goes to infinity, we will discuss. So I will focus the right side of this graph. For the 1 over x square function, the graph of the 1 over x square, like that one, let's use the different color, like this one. Okay, they intersect when x equals 1. At this point here, x is 1, also y value is 1. The red one, g of x equals 1 over x square. The blue curve is f of x equals x square. On this example, we can make some observations. So in general, we can say that for the function f of x equals x to power p, there is no upper bound on the values of x to power p when x increases. So we indicate this behavior as the following limit. When x approaches infinity, x to power p goes to infinity. Okay, or x to power p goes to infinity as x goes infinity. And similarly for the function g of x, which is 1 over x to power p, since this is reciprocal of very large number, and which is very small numbers if x is very large number, it follows that 1 over x to power p approach to 0. So 1 over x to power p approach 0 when x goes to infinity. Okay, biologic limit notation, limit when x goes to infinity, 1 over x to power p equals 0. we see that situation on this example. When x goes to infinity, x square goes to infinity, y value goes to infinity. And when x goes to infinity, 1 over x square approach 0. So this is that case, okay? If this p is odd number, for negative value of the x, it goes to 0 from below. But here, for negative value of the x, again, it will be approached to 0 again. So left part of this graph, maybe we can sketch like that one. This is symmetry about the y-axis. Limits of power function when x decrease without bound behave in a similar manner with two important differences. First, if x is negative, then x to power p is not defined for all values of p. For example, if p is 1 over 2, it is not defined, okay? For negative value of x, let's write for p equals 1 over 2, f of x will be x to power p, which is 1 over 2. So this is square root of the x. So the domain of the f is positive real numbers. Maybe we can include 0. So let's write in that form 0 to infinity. For negative x, it's not definite, okay? Second, if x to power p is definite, then if may approach infinity or minus infinity. This is the second important difference, okay? Depending on the value of the p. For example, limit when x goes to minus infinity, x square goes to infinity, but limit when x goes to minus infinity, x cubed goes to minus infinity, okay? Maybe you can recall that graphs. This is the graph of the x square. So here, when x approach to minus infinity goes to minus infinity, y value goes to plus infinity, go to up. And for the graph x cube, the graph like this one. So now when x goes to minus infinity, y value goes to y value goes to minus infinity. So this limit equals minus infinity. And I would like to say some other things. Let's turn back to the previous example, x square example. Here, x-axis, which is y equals 0 line, x-axis is a horizontal asymptote for the 1 over x square. Why? Because when x goes to plus infinity or minus infinity, g of x approach to 0. So in general, if f of x, limit of the f of x approach some real number like 0, 1, 2, minus 1, pi, e, etc., when x goes minus infinity or infinity, we say y equal to that value 1, 2, minus 1, pi, etc. is a horizontal asymptote, okay? So let's write down this situation as a definition. A line y equals p is a horizontal asymptote of the graph of y equals f of x if f of x approach b when either x increase without bound or x decrease without bound. So x goes plus infinity or minus infinity. So this is interpreted mathematically and symbolically by the following way. If limit when x goes minus infinity f of x equals b, or limit x goes plus infinity f of x equals b. If one of them is actually enough for this two limit. If you have a different limit value, for example, this is B, this is C, so you can say y equals B and y equals C is a horizontal asymptote. Y equals B is from the left side, y equals C is from the right side, etc. When solving the question, you will see that differences. So briefly here, in the first case, here, the graph of f will be close to the horizontal line y equals b for large in absolute value, for large negative x. In the second case, the graph will be close to the horizontal line y equals b for large positive x. Let's show that some situation about this case. For example, let's consider this graph. This is y equals b. Let's say this is y equals c. According to this graph, c is negative, but it does not have to be negative. So this is the graph, for example. Maybe we can sketch some known graph, but symbolically I show that, okay? This is the graph. So right side says limit when x goes to infinity, f of x approach to b. Left side says limit x goes to minus infinity equals c. Okay. So according to these two limits, we can say this graph is correct. And y equals b and y equals c are horizontal asymptote. The graph of the function f of x has the two horizontal asymptotes.